So I have it recording now.
Right. Okay, this is, so it's recording now?
Yep.
All right, let's leave the lights on for the moment. This is, I took it from Anthony Z's book, Einstein Gravity in a Nutshell. Of course, his nutshell is nearly 1,000 pages. The book is that thick. But it's a nice story, and it's by I. Bernard Cohen, who's an historian of science. And Cohen was quoting Einstein. Cohen visited Einstein on his last, or next to his last birthday, and so let's see, maybe I'll cut the lights and then show you the demo that is being talked about. Okay, so this is an example of good writing and an example of the equivalence principle, and then I'll do the demo of the equivalence principle, so I think that's useful. So he says here, at last I was taking my leave. Suddenly Einstein turned and called, wait, I must show you my birthday present. Back in the study I saw Einstein take from the corner of the room what looked like a curtain rod, 5 feet tall, the top of which was a plastic sphere about 4 inches in diameter. You see, said Einstein, this is designed as a model to illustrate the equivalence principle. A big grin spread across his face, and his eyes twinkled with delight as he said, and now the equivalence principle. Grasping the gadget in the middle of the long brass curtain rod, he thrust it upwards until the sphere touched the ceiling. Now I will let it drop, he said. And according to the equivalence principle, there will be no gravitational force. So the spring will now be strong enough to bring the little ball into the plastic tube. With that, he suddenly let the gadget fall freely and vertically, guiding it with his hand until the bottom reached the floor. The plastic sphere at the top was now at eye level. Sure enough, the ball rested in the tube. So the idea here is that there's a spring in the tube that isn't strong enough in an ordinary gravitational field to pull the ball into the cup. So let me get the... So this is the ball, this is the cup, and you see if it just sits here, it's not strong enough, there's a spring in here, it's not strong enough to pull the ball up to the cup. On the other hand, actually, can you turn the lights on now? So, well, I can do it maybe. Right, okay. So now what I'm going to do is what Einstein did. Raising it up there to the ceiling, and you see it's not full, well, I'm going to wait till it stops. Well, that might take a while. All right, I'm just going to let it go. So you see, in free fall, in the reference frame, the free falling reference frame, there's no gravity, and so the spring is strong enough to pull this thing in. So why don't I do it again? And in fact, if any of you want to do it, we can do the demo several times. Who wants to do the demo? Come on, somebody wants. All right, come up here and do the demo. So basically, you hold it, then you let it go, and then stop it. Oh, we've got a rubber stopper now, so that it doesn't break anything. Okay, good. So here, you raise it up and then let it go. Oh, that's right. You got to. Bravo. All right. Who else wants to do it? Come on.
I'll do it.
Okay. Well done. Anybody else? Okay. I think this is a cool demo, and it does illustrate the equivalence principle. So guess I'll just put this here for now, and, oh my God. This is so annoying.
Wait.
Is
click
there a
the little
way of
box
dealing
underneath.
with it?
When you hit login.
Yeah, the thing underneath hit the
Oh,
box.
hit login?
Yeah.
So, I'm sorry, right? It's gonna take you to the webpage.
And now I
exit
can
it.
hit the red dot?
Yes.
All right. Okay, so that's one example of good writing. Now, in fact, one student wrote me, said that he had looked at some of Newton's writing in Principia, and Newton was very wordy, and so how is this that Newton could be wordy, and Newton's famous, and what's the story with my advice to use as few words as possible? Well, what Orwell said was not to use as few words as possible. What he said was to use as few words as you need, to use only as many words as you need to say what you want to say. In other words, he said here, if it is possible, take a word out, cut it out. What he meant was, if it is possible without changing the meaning, to cut a word out, then cut it out. And now, of course, Newton was writing, 300 years ago in a totally different context, so it's crazy to imitate Newton, I would think. And I mean, he had to explain things that we take for granted. Okay, I thought I would show you, and there's another example of good writing, and something that's in the news, namely the indictment of Special Counsel Mueller. This is an example of good writing of a very, very different kind, but I think it's good to see many examples of formal writing that are good, so that when you're writing physics, if you need to depart from what you normally see in physics articles, you can sort of have a little bit of, you know how far one can go. Here's the website, and I'll put this new version, this new PDF on the class website this afternoon. Anyway, item 39, the lawyers probably have a different name than item. Oh, goodness. I can't even get this thing to go up. All right, here. So item 39 was use of U.S. computer infrastructure. So he says, to hide their Russian identities and organization, which was defined earlier, affiliation, defendants and their co-conspirators, particularly Polozov and organization's IT department, purchased space on computer servers located inside the United States in order to set up virtual private networks, VPNs. Defendants and their co-conspirators connected from Russia to the U.S.-based infrastructure by way of these VPNs and conducted activity inside the United States, including accessing online social media accounts, opening new accounts, and communicating with real U.S. persons while masking the Russian origin and control of the activity. So I don't think we can easily find a word that we can take out that doesn't change the meaning. And I picked this section simply because you guys are all interested in computers. So the second, item 40 was defendants and their co-conspirators also registered and controlled hundreds of web-based email accounts hosted by U.S. email providers under false names so as to appear to be U.S. persons and groups. From these accounts, defendants and their co-conspirators registered or linked to online social media accounts in order to monitor them, posed as U.S. persons when requesting assistance from real U.S. persons, contacted media outlets in order to promote activities inside the United States, and conducted other operations such as those set forth below. Then the next one, item 41, was use of stolen U.S. identities in and around, this is something that I thought was nice, that they are careful with time and are willing to use an extra word or two to be precise. So in or around 2016, defendants and their co-conspirators also used, notice used, not utilized, also used, possessed, and transferred without lawful authority the Social Security numbers and dates of birth of real U.S. persons without those persons. Okay, that was an apostrophe there, and unfortunately when I moused it in it became a question mark, so that should be an apostrophe. Knowledge or consent. Using these means of identification, defendants and their co-conspirators opened accounts at PayPal, a digital payment service provider, created false means of identification, including fake driver's licenses, again the question mark at home, and posted on organization-controlled social media accounts using the identities of these U.S. victims. Defendants and their co-conspirators also obtained and attempted to obtain false identification documents to use as proof of identity in connection with maintaining accounts and purchasing advertisements on social media sites. Okay, so those are just some examples of a different kind of writing. Here's a third example. Any questions or comments? Let me just add one thing that I noticed. I read the whole indictment. Somebody said that it was a good read, so I thought I'd read it. It's 37 pages. But it's kind of interesting. Well written, as I said. One word they use is persona, and they use the English plural personas rather than personae, which would be the Latin plural. And it turns out persona, I Googled it just to make sure I got the Latin right, because it's been many years since I studied Latin. And it turns out persona means mask in Latin. And so these personas are, in other words, they created personas that weren't real people and pretended to be American citizens. Okay, anyway, here's an example of good writing from what is at least arguably the best textbook, science textbook ever written. It's called Molecular Biology of the Cell, and it is just, I think, a remarkable, remarkably well written. It's just a great book, remarkably well written. In fact, you can download, I don't know if it's the latest edition, but a recent edition of it you can download as a PDF file from a website called b-ok.org. And maybe I should write that down. The website is b-ok.org. You can't Google a site because Google deleted links to it, but if you just type in that, you can get to the site. Anyway, you can download a PDF of this book, and the first 5 or 6 chapters read like a thriller or a science fiction novel. They're real. It's so well written that it's just fun to read the first 5 or 6 or 7 chapters. Yeah.
Who's the author?
That's interesting. The author is 5 or 6 of the top biochemists. And I talked with one of them at a biophysics conference a few years ago, and he said to me that the authors all trusted each other so much that they used a wiki model to produce new editions of the book. In other words, any of the 5 or 6 authors could change any sentence in any author's any sentence in the book, no matter who had written that sentence. And so they all corrected each other's mistakes and improved and added things, and apparently did so in just a marvelous way. So, shall I read this or let you read it? What do you think? All right, I'll read it if there's no rule. All cells replicate their hereditary information by templated polymerization. The mechanisms that make life possible depend on the structure of the double-stranded DNA molecule. Each monomer is a single DNA strand. That is, each monomer in a single DNA strand. God, I can't read. That is, each nucleotide consists of two parts. A sugar, deoxyribose. It's just a sugar that has one fewer oxygen atoms than a normal sugar, a normal ribose. A sugar with a phosphate group attached to it and a base. And the base may be adenine, guanine, cytosine, or thymine, and the figures down below. Each sugar is linked to the next via the phosphate group, creating a polymer chain composed of a repetitive sugar-phosphate backbone with a series of bases protruding from it. In case some of you haven't had biology, let's just look at it. There's the sugar with the phosphate, there's the base. The base attaches to the sugar like that, and then you have a sugar-phosphate, sugar-phosphate, sugar-phosphate backbone, and then a base, one of the four bases sticking out to the side. And then the bases are such that they join, A and T join to each other, and C and G join to each other, but not otherwise. And notice that with C and G, you get 3 bonds going across, whereas with A and T, you only get 2. Anyway, to get back to this, where was I misreading it? The DNA polymer is extended by adding polymers at one end. By adding monomers, God, I can't read the damn thing. For a single isolated strand, these can in principle be added in any order because each one links to the next in the same way through the part of the molecule that is the same for all of them, that is the sugar phosphate part. In the living cell, however, DNA is not synthesized as a free-strand in isolation, but on a template formed by a pre-existing DNA strand. The bases protruding from the existing strand bind to the basis of the strand being synthesized according to a strict rule defined by the complementary structures of the bases. A binds to T and C binds to G. This base pairing holds fresh monomers in place and thereby controls the selection of which one of the 4 monomers shall be added to the growing strand next. In this way, a double-stranded structure is created consisting of 2 exactly complementary sequences of A's, C's, T's, and G's. The 2 strands twist around each other, forming a double helix. So there's the picture of the double helix. Okay. By the way, I don't know if I mentioned this, but it's a mathematical theorem that if you have a bunch of identical blocks and you connect one to another in exactly the same way, you automatically generate a helix. Okay,
it
let's...
makes no sense because what if you have a cubic lattice? It's not a helix.
Well, it's a degenerate case. In fact, there is a case in biology that is degenerate, and the biologists don't call it a helix, unfortunately. Namely, Linus Pauling discovered the 2 forms of proteins, or 2 structures that are common in proteins. One is the alpha helix, and the other is the beta strand. And in the beta strand, the thing is actually a helix, but the angle of rotation is 180 degrees, or almost 180 degrees, so it looks flat. Doesn't look like a helix to the eye.
What does it mean, degenerate case? What does the term mean? The term degenerate?
Well, degenerate in the sense of the sort of falling apart. In other words, but I should have said special case. In other words, if you connect things by each one is rotated from the previous one by 180 degrees, or by 360 degrees, or by 0 degrees, it's still a helix mathematically. It's just doesn't look like one, so it's a special helix. Here I've got, let me just do command minus. Let me just mention, I haven't actually started to write this chapter. I haven't written more than 2 sentences in this chapter. The first sentence is avoid irregular verbs or Google them, so don't make mistakes with them. Also avoid hopefully, which actually means in a manner full of hope. It doesn't mean I hope. And so it's now hopefully, so many people use hopefully incorrectly that it's presumably standard, and if you use hopefully correctly, you may be misunderstood, so it's best to avoid hopefully. All right, let me get to something else. In fact, what it was that took me so long to get here today, which is irregular verbs, the ones I told you to ignore, or not ignore, but to avoid if possible. And that's because this part of the language is changing rapidly. Languages evolve, usage changes, and boy, it is really hard to move this stuff around. All right, I think we're here. Okay, so here I got from the web this afternoon a list of irregular verbs, but before that, let me just say what I wrote before that, if we can find it. Yeah. Okay, so languages evolve and usage changes over periods. In fact, these periods can be as short as a few years. Now, I enjoy listening to speech like me and him went fishing. I think it's amusing, and it may become standard English in 100 years. As I said to you before, one of the smartest people I know actually speaks that way. It may have hurt him academically, actually. One colleague of mine said, have you seen the way he writes? In fact, this guy is actually very, very smart. And I think he writes, I think he probably writes pretty well. Anyhow, so the thing to do is to avoid rapidly changing usage, because if you use the traditional standard usage, then some person might think you're being pretentious or might not understand what you're saying. And then if you use the most modern usage, other people will say it's wrong. So it's basically, it's a good idea to avoid rapidly changing expressions. And of course, also if you're writing a physics article or giving a formal talk on physics, you want to avoid outright grammatical mistakes and also avoid changing usage. Now, the irregular verbs of English are slowly changing, so in formal writing and speaking, one should either avoid them or use them correctly. So I thought I would put on this, I would make a list of these. I didn't make the list, I grabbed it from the web, and it turns out amusingly that if you Google irregular English verbs, the top few hits are not English language sources, they're German. So apparently the Germans...
But some of them are impossible to avoid, like can you really avoid the word be, for example?
Give me that again?
Some of the words on the list are impossible to avoid, like can you avoid the word be, for example? Or do
No, all right, no, I completely agree with you. I completely agree with you. You can't avoid some of these irregular verbs. And in fact, the crazy thing is that the verbs that are irregular are the most commonly used, among the most commonly used English verbs. So, but on the other hand, some of them aren't really changing very much, and then some of them are. In the Southwest, the verb lie is changing a lot. And in fact, a school teacher, some school teacher once said that told either my wife or me that the state government of Texas had defined the correct form of lie, thus and so. And all right, anyway, so I just thought I'd list these. I guess one doesn't have too much trouble with cut, but anyway, so if you guys are writing something and you want to download this PDF from the class webpage, you can consult it, because you can also just Google the verb in question. As I said, this lie, lay, and lane is one of the tricky ones, and it gets confused. This is the intransitive verb, like he is lying on the couch, or he lay in bed all day, or he had lain in bed until the alarm clock went on. And it gets confused with the transitive verb, L-A-Y, which apparently is regular because it didn't make this list, so it just takes ED at the end. So let's see. We've got about 10 minutes or so left. Does anyone have any comments about these verbs or? It seems to me that most of them are. I think the only one that's changing much is the word is lie. Well, beat is a. Let's see. Do we hit beat? Beat isn't there. That's curious. Or break, that's it. Break, broke, broken. Yeah, they left beat out. Maybe I'll add it in. Okay, anyway, so basically, if you're not sure of what the present past or past participle is of some irregular English verb, you just Google it. Or ask the Germans. One efficient way of holding future classes is for you guys to do what I asked you to do on day one, which is to write something up and send me a text file, not a picture, but a text file, and then we could collectively try to improve the what was written. Now, what I might do is bring you guys next time some of my own writing and see if you guys can improve it. As it is, I'm working on the second edition of my book on mathematics and for physicists, and one of my colleagues said it has too few words. I was, of course, trying to follow Orwell's rules, and I actually have included more. Let's see, can Can I just get this thing to move somehow more rapidly here? Rather than scrolling?
If you go to, yeah, click that.
Let's see, sidebar.
Go down to continuous scroll.
Maybe tables of con, no. Yeah, here we go. Okay. I think, didn't? Well, we can go to Glauber's example. Okay, so examples of good writing. So we did the Sidney Coleman and Weinberg, by the way, wrote a book called The First 3 Minutes, and it and it is quite good, and I'd recommend that as an example of good writing, but it's popular rather than hardcore physics. Okay, so this is one of Glauber's famous papers, and I just randomly picked some sentences that I thought would be examples of good writing. So he says here, we are led then to distinguish among various orders of incomplete coherence according to the number of conditions satisfied. He had previously said that he described various conditions for coherent light, or coherent fields. The fields traditionally described as coherent in optics are shown to have only first-order coherence. The fields generated by the optical maser, on the other hand, that's what the laser was called back in the early 60s, may have a considerably higher order of coherence. Then he goes on to say, it hardly seems that any justification is necessary for discussing the theory of light quanta in quantum theoretical terms. This is because the optics have been discussed classically so much, for so long, like 100, 200 years. This is another paper of his, also at the same time. These are the papers that basically got him the Nobel Prize in physics. Methods developed for discussing the photon statistics of arbitrary radiation fields in fully quantum mechanical terms. In order to keep the classical limit of quantum electrodynamics plainly in view, extensive use is made of the coherent states of the field. These states, which reduce the field correlation functions to factorized forms, are shown to offer a convenient basis for the description of fields of all types. Although they are not orthogonal to one another, the coherent states form a complete set. It is shown that any quantum state of the field may be expanded in terms of them. I think he should not have added that last phrase in a unique way. There are many ways of actually expressing the field in terms of the coherent states. Anyway, expansions are also developed for arbitrary operators in terms of products of the coherent state vectors. These expansions are discussed as a general method of representing the density operator for the field. A particular form is exhibited with the density operator, which makes it possible to carry out many quantum mechanical calculations by methods resembling those of classical theory. This representation permits clear insights into the essential distinction between the quantum and classical descriptions of the field. It leads, in addition to a simple formulation of a superposition law for photon fields. Detailed discussions are given of the incoherent fields which are generated by superposing the outputs of many stationary sources. These fields are all shown to have intimately related properties, some of which have been known for the particular case of black body radiation. Okay, I think that's the last of the examples of good writing. You guys may have some questions about what that section that I just read. Pop up the question. And, actually, some of you may have asked questions and not gotten candy. Actually, I think anybody who did the demo gets a candy. Who else did the demo? Was there only 2 demos? So, what about questions on what Glauber was saying? Yes.
Why did the name change from Mazer to Laser?
Oh, in the first ones were microwave frequencies. So it was microwave amplification, I guess was MA. I don't remember but
Unit stimulation.
and also you had to say optical maser. So if you just say laser, it's light amplified by the stimulated emission of radiation. So maybe maser, microwave amplification by the stimulated emission of radiation. I might say something about the coherence. All right, this will just take less than a minute. If you have one mode, you know what you can do. You know how we use harmonic oscillators all the time whenever we can in physics. In particular, for each mode of a quantum field, at least a bosonic quantum field, like photons, gravitons, Higgses, and then the W and the Z, which of course you don't see every day. Anyway, for each mode of such a field, one uses a harmonic oscillator variable, and one rewrites them as what's called an annihilation and a creation operator. The operator A is something like 1 over square root of 2h bar. I'm just guessing actually. Q plus IP, and it's really lambda Q over lambda P, I think, or maybe square root or something. Anyway, it's just a parameter. And quantum mechanically, you have the commutation relations QP is IH bar. Well, by using this notation with an arbitrary lambda, one gets operators that do that. Then a coherent state alpha is e to the minus a half alpha squared times the sum n equals 0 to infinity alpha to the n over the square root of n factorial times the state n, where the state n is the is a state. In other words, the basic Hamiltonian is h bar omega a dagger a. I'll put in a plus 1/2, but the main thing is h bar omega a dagger a. And the eigenstates, the eigenvalues of a dagger a are 0, 1, 2, 3. They're the natural numbers. And so n is that eigenvalue. And this thing is a dagger raised to the n on the state 0, which is called the vacuum state or the ground state. It's the ground state of this particular oscillator, and A annihilates the ground state, and that is now there's a I think we have to divide by a square root of either n or n plus 1 factorial. I don't remember. It's one or the other. And anybody remember? It's one or the other. And anyway, the important thing is each one of these a daggers takes you from 0 to 1, from 1 to 2, and so forth as you hit it again and again. And the cute thing about this coherent state is that it's an eigenstate of the annihilation operator with eigenvalue alpha, where alpha is an arbitrary complex number. And so what Glauber did with these coherent states, you see, is that you can imagine that the vector potential is a sum e to the I kx minus omega t, and then a, and then some polarization back there, and then plus e to the minus I kx minus omega t, a dagger epsilon star, and you sum over various k's. So this is the quantum version of the electromagnetic potential. The curl of A gives you B, and A dot gives you E apart from the Coulomb field. And the point is then that if you have a matrix element of this between a coherent state beta and the coherent state alpha, where you have a different alpha for each mode corresponding to the K here and the polarization, then this thing is the same thing except that A gets replaced by alpha K and a dagger gets replaced by beta star. So in other words, when you take coherent state matrix elements of electromagnetic field, quantum fields, what you get is something that is a complex number, and it's a complex number that's related to the quantum field by replacing the operators by their eigenvalues. And so what he was able to do was to join to make a theoretical continuum between classical optics and quantum electrodynamics. And so all of a sudden the whole thing could be viewed as one subject, and you could view everything the same way. And okay, so we're out of time now. Any questions?